Yeah, so this week what we will do and what I will introduce you is basically these kind of nice Python packages that can be used to work with OpenStreetMap data. How many of you are familiar with OpenStreetMap data? I guess it's something quite commonly used in geography and GIS. So you know that already. The idea is to basically see how we can actually download OpenStreetMap data straightly from Python, how to do basically, how to visualize that data, and then how to use the road networks from OpenStreetMap data to conduct simple network analysis. So what we are basically focusing today is to give you an introduction how it's possible to, for example, calculate the shortest path based on street network in Python. And basically after this lesson you should know how to do that and how to also extract some simple street network properties and statistics such as centrality measures and so on. So let's start. Maybe a bit of background information about OpenStreetMap. So even though most of you already know what it is, but OpenStreetMap is really this kind of global collaborative project that aims at creating this kind of free editable map of the world, and it contains a lot of information about streets, buildings, land use, points of interest such as services and their opening hours and so on. And what is really cool about it is that basically every one of us can go and actually edit that data and improve it and so on. So it's quite interesting project and really important for GIS, as it's fully open source and it's all free, cost free, so you can use it for any purposes and so on. It has a quite large user base, so there are more than 4 million users actually contributing to the OpenStreetMap, and basically there are more than 4 billion nodes in the dataset. And the quality of OpenStreetMap is quite good, especially in kind of urban areas such as Helsinki and all the big cities. And there are a lot of studies kind of assessing the quality of the OpenStreetMap. And I guess, I think it's kind of one of the best datasets available that have such a broad coverage globally, as basically people everywhere in the world are actually making it better every day. How you may have used OpenStreetMap this far, so it's quite typical to have an OpenStreetMap as a background map if you are visualizing some or making some map with some of your analysis or so on. But it's also used for routing, which we will learn today a little bit. So basically finding, or for navigation, basically it can be used. We already used OpenStreetMap data for geocoding. So in lesson 2, if I remember right, lesson 3, we used this nominatim service for putting addresses and getting them as coordinates back. It's also used for education, and a lot of research is also based on or used. A lot of research uses OpenStreetMap, such as my own research. And then it's also widely used for humanitarian response. How many of you are part of HotOSM or have used HotOSM? Yeah, so it's it's really important and nice that there are this humanitarian work and that basically will give humanitarian response in crisis areas like after earthquakes, where when everything goes differently. So there is usually like right after people are taking satellite photos or using satellite photos and actually digitizing the kind of what are the routes in the area and so on. So helping out in those regions which have some difficulties, such as natural disasters. Yeah, so that's a bit of background from OpenStreetMap. What we will mostly focus and use today is this Osmnx. So it's this kind of quite cool new Python package developed by this one PhD student from Berkeley, California. And basically what he have done is that he have created the package that makes it really easy to actually interact with OpenStreetMap, like download the data from certain areas and analyze that street data and basically also do some network analysis and build the networks. The name basically combines this OpenStreetMap, so OSM, and the other one is NX, which comes from a package called NetworkX, which is basically a Python package used for analyzing complex networks, and that can be used to basically do this kind of shortest path analysis and do routing using street networks and so on. So let's start and see what we can actually do with this Osmnx package. So basically the aim, what we will do now, is to basically create this kind of map and extract the data from OpenStreetMap. So we have certain areas, so Kamppi in Helsinki, and we will extract buildings and the polygon area and the roads from that area and basically make a nice map out of it. And it's actually fairly straightforward to do, so let's see how we can do it. So I already have my Spider open. So basically again we start by importing some modules. So what we are using here is indeed the import Osmnx.
First question.
Yeah.
The exercise says till lecture of next week, but we don't have lecture next week.
I thought I fixed that, but yeah, we don't have lecture, so yeah, it's just by next week. Yeah. So there will be practical sessions this week, but there is no lecture anymore next week. So that's a mistake. So yeah, but let's continue. So import Osmnx as OX. And what else do we want to import? Well, we want to plot the thing, so we import the matplotlib library as well. So basically how this Osmnx, it's really difficult to pronounce, Osmnx works is that you can basically kind of search data from OpenStreetMap by specifying an address or specifying a place name, or then you can basically specify that from this point take from 1 kilometer radius, bring all the streets from that area, or then you can also basically put the bounding box and basically specify that in that way, like the area where you want to search the data from. In the lesson materials, we will only use the kind of address and the place name, what we will use to retrieve the data. But there are links in the materials to other tutorials from the package maintainer that will show all the other possibilities that you can use, so you can find information from there as well. But first, so I will now use and search the data based on a place name. So place name, which is used to retrieve the data from OpenStreetMap. So basically what I will do is that as I said, we want the data from Kamppi, which is a kind of city district in Helsinki. So what we can do, what this is actually using is indeed the nominative that we used already in lecture 3. So you have kind of already used this service, and that package Osmnx uses that as a background, or that works in the background. So I want to retrieve the data from Kamppi, Helsinki, Finland, and that should be enough to be able to search the data. So how we can basically retrieve the street network from OpenStreetMap using this package is by using this, so I will call this as graph. So the street network is one kind of graph, as you might know. So in this Osmnx package, we have this function called graph from, and now you can already see that there are graph from address, bbox, place, point, polygon. So you can basically use different kind of, there are different ways of retrieving the data. What we will use here is that I want to use this place. So basically I want to find OpenStreetMap data using that place name that we defined there. So this is quite simple with 2 commands. Oh, well, I need to run these things. So import those, put a place name, and now with basically 1 command we can get the data from OpenStreetMap. It might take a while, especially now because Kamppi is rather small area. It didn't take too long to download the data, but thinking of if you try to fetch all the data from, well, Finland, it might take forever. So I kind of recommend maybe doing them in smaller patches when doing so. But Kamppi works nicely. Also Helsinki region is fairly quick to retrieve and so on. But of course the larger area you fetch, the longer it takes. So now we have this graph, and let's take a look what it is. So indeed, now we can see that the data type that we have here is this kind of network X class, and the network X is kind of the package that allows to analyze the network data, so street networks for example. And this multi-graph is basically this kind of data type that stores the nodes, so the kind of nodes and edges. So if you have an intersection, so that can be one node, and the edges are actually the roads between those edges, and so on. There is a link in the materials. So there is a link to the network X package, and I recommend checking out this package. It has a lot of features if you are interested in kind of doing network analysis. So it has a lot of features and functions to work or to deal with networks. And one of the things that we will use today is indeed these shortest paths algorithms that can be used to analyze and find out or optimize routes between locations. Yeah, so that kind of data type we have. So now we have the data in. Let's see what it actually looks like. So this Osmnx has a nice function to actually plot the street network and the nodes in a quite nice manner. So plot the network. So basically what it will return matplotlib figure and axis. So this OX plot graph, and then we basically put what graph do we want to plot. So it's that one that we just downloaded. So by running this, we basically get quite nice visualization of the road. So we can now see that Kamppi region seems to look like this. So we have plenty of roads, and these white small circles are basically the nodes of the network that we have. So that was fairly easy. So it's not really difficult to fetch data from OpenStreetMap with Python. Let's see how we can actually fetch some other type of data. So now we fetch the street network. Let's see how we can fetch the area polygon. So kind of the delineation of Kamppi district. So it's somehow defined in OpenStreetMap, so we can actually fetch that that polygon, fetch the Kamppi area. So we can say that area equals to OX, and again we have this. Now we are actually not fetching a graph, we are actually fetching geodata frame. So what this function will give as return is a geodata frame, and we have this GDF from place function, and here we can basically again put the same place name, so the Kamppi, Helsinki, Finland. And let's see if we do that, and let's also plot it. Actually first we can check that the type, well indeed it is a geodata frame. Let's take a look, what do we have? Well, we have some kind of bounding box here, we have the polygon geometry here, and then we have the place name. And as this is basically a geodata frame, we can just say that area.plot, and with this function we can get the area and see how it looks visually. One really useful feature is that in quite often you might want to have information about the buildings in the region. So there is also a kind of nice function to retrieve buildings from OpenStreetMap. So we can say that buildings equal to OX dot buildings from place. Yeah, this one, and again put the place name here, and now let's download the data from OpenStreetMap. And again, this is a geodata frame that we have. So indeed, and we can take a look what kind of columns we have. We have quite a lot of data included, so there is actually 70 columns in this building. So there is a lot of information associated with each building in the OpenStreetMap database. And yeah, let's take a look what kind of columns do we have. So this is basically a list of all different columns. So we have different address information in there. We even have what color the building is. what material, some contact information such as website, email, height, ice cream, there is a tag for ice cream, what kind of land use there it's basically on, and the name of the building, and so on. Is there something else useful? There is a wheelchair, so is it accessible by wheelchair, and so on. So indeed, even Wikipedia links might be there, and so on. So there is a lot of information available from those buildings, and well, it can be useful if you are doing any analysis on urban areas in your work or in the studies that you are doing. So really easy to get this building information from here. So basically what we got here is that the area and the buildings, they basically came as geodata frames, but the graph, as you remember, it was this other data type. So it was this network X multi-graph data type, which is this kind of network data type used by network X. But we can actually kind of convert that network X graph into geodata frames, and there is a really handy function to do that. So let's say convert NX graph to geodata frames. And actually, as you might, how many of you are familiar with kind of network and the structure of networks? Like, what are the components of typical network? It should be in GIS quite familiar thing. So there are nodes and there are edges and so on. So and links between the nodes and so on. So what this graph includes is indeed that it has the nodes and it has the edges. And basically when we convert that graph into geodata frames, we actually get two different geodata frames. So one data frame is just containing information about the nodes, and the second one is containing information about the edges of the network. So let's see how we can do that. So we actually use a function that returns, as I said, two data frames, so nodes and edges, and there is this function called OX graph to GDFS. So graph to geodata frames, and basically what we put as an input parameter is the graph that we downloaded, and executing that, what we have is, as I said, geodata frame, and let's say take a look at the other edges. It's also a geodata frame, and let's take a look at the data. So what we have here in the nodes is that there are few these kind of OpenStreetMap tags associated with it. There is this OSM ID. This is basically the ID of the element, so ID of the node, and it's a unique ID for each element in OpenStreetMap. Then there are the X and Y coordinates of that point, so that node, and then there are the actual geometry. And of course now this is a geodata frame, so we can plot it. Let's take a look. So this is how it looks like. We have plenty of nodes in Kamppi region, so every intersection basically has one node, and so on. So that's the nodes. Let's take a look of the edges. Edges.head. So again, we have a lot of information. There are some tags such as is the kind of edge, is it a bridge or not? how many lanes the edge might have. There are 2, 4, and so on. What is the length of the street element, so the edge? This is in meters basically, so one seems to be 6 meters, and there is one element that is 40 meters, and so on. What is the speed limit of that can be taken on that street, and so on? What is the name of it? Is it a one-way or not? If it's true, then it's one way. If it's false, then it's not one way. Then there are the IDs for these, and so on. And these U and V, they are basically network X related. So they are the kind of the OSM EDs for the start and the end node, and the IDs of those. In the website there is a table basically somewhere. Well, not here. It comes in the next topic. But there is a list on the website or table explaining these different or some of these variables here. So now we are in a situation where we have all our data in geodata frames, and basically we could start working with those geodata frames in a similar manner as what we have done so far. So all the techniques that you have learned are available. You can select some data and create different kind of visualizations and so on. Let's now create basically the map that is shown on the website. So visualize the OSM data. So what we can do is indeed that we use the kind of matplotlib way and using GeoPandas to visualize the data. So we start by specifying a figure and the axis by saying pld.subplots, and now we have an empty figure. And then what we can do is that we basically can specify that we want the area of that compy to be at the bottom. So let's say that area.plot, and we want to plot it using the axis that we just created, and we can specify that the face color, so what kind of color we use for this polygon is black. Then let's put this a little bit higher. Then let's plot the edges, so the streets on top of that polygon. So we can say that edges.plot, again we use the same ax, so this will be plotted on top of that. We can say that the line width, so how thick the line should be, or the streets, well, let's put it 1. And let's say that the edge color, so what color those lines should be. We use this some hex code called 8C8 F8F, and this is some brownish red brown color code for that. And then let's plot the buildings on top of that. So buildings plot x equals to x. Face color, let's put this nice khaki color, and let's put some transparency to those buildings by specifying the alpha. So let's say that it should be 70%, so 30% is transparent here. And basically when I run all of these buildings, it should be buildings. Let's do it again. And now we basically get the same figure, although it seems my roads are a bit different color as it should, because that is not number 8, but it's letter B. So now we should get it just as it is. And yes, now we have a map basically showing just this. And basically what you could do, as you can see from this map here, for example, is that we have a lot of roads here and a lot of buildings and so on. But because we basically have the information about the edges, for example, and there is this highway tag, for example, here that we can use. Let's see what we have there. Edges highway dot unique. Okay, it seems to be if you receive this kind of unhashable type list, it means that the highway kind of column contains not only strings, but it also contains some lists. So we need to, how we can get rid of this error is that we convert that highway into a string, so that the lists are not represented as list, but they are kind of strings that looks like a list. So we can say that edges highway equals to edges highway as type string. And now we should be able to get the unique values from here. If we want to see all of them, as this now kind of removes some of the values, we can say that list unique, and then we will get all of these values out of here. So these are basically representing all the kind of different kind of street types or road types that are available. So we have some cycleway, footway, some residential roads, some pedestrian roads, some service roads, tracks, corridor, and so on. And as you can see, there indeed were a few of these lists inside, and basically this is when one street has actually, so it's not only residential road, but it's also a cycleway. So of course you can have these multi-purpose roads in the city as well. So that was what the Pandas was complaining about. So, but what we could basically do here is that if we would like to only visualize, for example, the let's say the cycleways. So what we could do is that let's make a small change in here. Let's say cycle roads equals to edges dot lock, and let's say edges highway equals to cycleway. So what we do here is that we just select those rows from the data and all the columns from the data where the highway tag is same as cycleway. So now we should end up having only those kind of features, cycle roads. Let's take a look, and now yeah, and now we only have those. And what we could do here is that instead of plotting all the edges, we can just plot the cycle rows, and we can basically see what kind of information OpenStreetMap has about cycling and cycle roads. So let's see how it looks like. Well, not good. There are a few cycleways here and there with the cycle tag. Of course, basically you can cycle whatever kind of road there is, but these are the roads that have been tagged exactly of being a cycled road. So yeah, so this is what you can do. You could do the same for drivable roads and so on from the data. Yeah, so that's what you can do, and basically the idea is that you can you can search for any place in the world. We could basically do similar thing for let's say Manhattan Island, New York, United States, and basically we could, maybe I first, before doing this, I check the correct not osmosis, it's different tool. Nominatim was the one that I was looking for. So Manhattan Island, New York. Yeah, so this is a good place to kind of, if you're unsure, then like what is the correct way of searching for a certain place, so we can basically come to the nominatim service and basically check it from here. And let's say, what do we have here? Well, we can just take the address Manhattan Island, Manhattan, New York City, New York, it's a long one, United States of America. And basically, well, what we can do here is that let's take a look how the cycle roads look in Manhattan. So I just run the whole script, and basically it might take a while, but at the end we should have a map out of Manhattan Island cycling roads. So it's pretty neat tool and really easy to use, so I can highly recommend it. And what is even nicer, being a scientist, is that basically, no, it was in the previous. So there is a scientific article about the tool. So if you're interested about different kind of methods that are available in this, so it's this guy, now I don't remember his first name, but Boeing, and he has basically written in this computer environment and urban systems, which is pretty highly appreciated journal. So he have written an article about this tool, which is of course also kind of proof of quality, that you can manage to go through the peer review system. So now we have the Manhattan and the Manhattan Island in New York, and what it did now was that it basically visualized it. Might take some time, but let's wait a while. So we should have the map of New York. In the meanwhile, so we will see that. And now we got some kind of map out of, I don't know if I can I, no, can I do it here? Well, it's a bit small, but anyway, we can see that there are a lot of cycle roads in New York, much more than in Kamppi. Of course, it's a bigger area as well. But anyway, if we would have this as a separate window, we could.
Try for a smaller area like Hell's Kitchen.
What, Hell's Kitchen?
Yeah.
What is Hell's Kitchen?
It's an area in New York.
Oh, I didn't know. What? How is it called?
Hell's Kitchen.
Hell's, really, like Hell's Kitchen, like
Yeah,
like that. Okay, well, what the heck? Let's do it. Let's see. Let's put this smaller. Oh yeah. Yeah. I don't know. Now I need to go and check where's the Hell's Kitchen. Yeah. There seems to be some series about it as well.
You need to watch Daredevil.
Okay, so it's that area. So a lot of nice Irish pubs in the area, I assume. Okay. Yeah, well, now there is 2 cycle roads in that area. Not that much, but yeah. Well, anyway, but you can play around, so the idea is that, yeah.
Sorry, I only joined like midway to the lecture, but what's the reason that the output map is kind of isometric?
You mean the orientation?
Yes.
Of course, well, you might guess from the kind of values in here. Well, what we have here is that we are using VGS84 projection. And of course, as we are quite north, so everything are kind of disoriented. Same thing as in Finland. Actually, next, what we will see is that we will project the network and all the data so that the map